Welcome back. I'm Kevin, and in today's episode, we're going to continue the discussions around home studio acoustic improvements. Now, everything we're going to talk about today can be applied to your studio, or your home office, or where your kids are currently doing their schoolwork. So let's get into that. In episode 3, I measured the room's RT60 with acoustic measurement tool REW, and detailed standard approaches to treating the room. After installing absorbers, I reswept the treated room and walked through the big improvements to RT60 after adding absorbers. But the addition of absorbers emphasized the remaining low-end mode issues that need my attention. So in this episode, I'll detail the traps I'll use to address the low-end issues. I'll install those traps, then resweep the room. Then I'll review the data plots, summarize the results, and detail the improvements made using these bass traps. If any issues remain, I'll set up an action plan to address them. So let's jump in. My goal with this project is to ensure this room meets my personal acoustic requirements. Like most musicians, I want to maximize the return on my acoustic investments while minimizing the impact on my financial budget. All right, let's do a quick refresh on the success measurements I'm using. I'm measuring the reductions to the RT60 for each 1/3 octave in the room as an indicator of improvement. So check out episode 2 for a detailed RT60 explanation. Here is the resulting plot of the RT60 data of this empty room. I've used a blue line at the top of the graph. Notice many 1/3 octaves are above 600 milliseconds. Referring back to the zones as discussed in episode 2, Zone 1, these octaves were below 28 Hz, and we're going to ignore them for now as they don't show on the plot. Zone 2 covers 3rd octaves, 31.5 Hz through 160 Hz, and we're between 500 and 600 milliseconds. Zone 3 covers 3rd octaves, 200 Hz through 1.25 kilohertz, and their RT60 was between 500 and 770 milliseconds. And finally, Zone 4 covers 3rd octaves from 1.6 kilohertz through 20 kilohertz, and we're between 600 and 740 milliseconds. So using those, I sort of averaged out the room RT60 was around 625 milliseconds. So now I'll overlay the RT60 data plot reflecting the installed absorbers. I've used a pink line and it resides at the bottom of the graph. So referring to the zones again, Zone 2 3rd octaves are now between 250 and 470 milliseconds. Zone 3 3rd octaves are now between 210 and 320 milliseconds, and Zone 4 3rd octaves are between 200 and 240 milliseconds. I've identified the need to resolve the low-end modes in Zone 2. So let's focus now on using bass traps to further improve the RT60 for octaves between 60 and 150 Hz. I chose a corner trap design that's pretty common on the internet. Utilizing available specifications and lab testing for similar corner bass traps, I knew these would work for my room, and here's how. On this mix chart, the pink columns are the current RT60 times for Zone 2 3rd octaves in my room. The blue line is the absorbency coefficients per Zone 2 3rd octaves, provided by the testing labs for these types of corner traps. I can see the trap's greatest absorbency covers my troubled 3rd octaves in Zone 2. Therefore, I'm pretty confident these are a great solution for my room. And in my case, I chose not to buy, but to DIY. And so here are some clips of the build and the installation of the corner traps. While reviewing different trapping options, I had seen these hybrid designs on the internet. Knowing I wanted trapping with some diffusion on my back wall, these piqued my interest. Using different sources of test documentation for similar hybrid traps, I landed on using this poly diffuser design in my room. Once again, this mixed chart, the pink columns, are the current RT60 times for Zone 2 third octaves in my room. The lime green line is the absorbency per third octaves provided by the testing labs for these hybrid traps. Notice again that the trap's greatest absorbency covers the third octaves in Zone 2 while minimizing unnecessary absorption in Zone 3 and 4. Again, I chose not to buy, but to DIY. Here are some clips of the build and the installation of these hybrid traps. This chart details my expectations that the two trap types should reduce the RT60 for the Zone 2 third octaves. The arrows note how the trap absorbency coefficient aligns with each third octave. So now that I've built and installed the base traps, I've used REW and the room has been swept again. Let's look at the results. Here is the data plot reflecting the new RT60 with additions of corner and hybrid traps. I've used a dark green line and it resides at the bottom of the graph. Referring to the zones again, Zone 2 third octaves are now between 100 and 250 milliseconds. Zone 3 third octaves are now between 190 and 290 milliseconds. Zone 4 third octaves are now between 190 and 250 milliseconds. It's important to note that the higher third octaves between 2.5 kHz and 10 kHz have increased as much as 40 milliseconds. This was expected and is due to the diffusion the hybrid traps add. This new chart shows the RT60 reductions in milliseconds between 63 Hz and 125 Hz. Notice that with the addition of these traps, the 63 Hz third octave has dropped 340 milliseconds. The others have dropped from between 120 to up to 250 milliseconds. So here's the final chart plot, contrasting the empty and treated room's third octave RT60s. I've achieved my goal for Zone 2 third octave RT60 times. So now I'll open the topic of not to buy, but DIY, and compare in detail the cost benefits of treatment options. If I were to purchase off the shelf all of the absorbers, traps, and diffusers used in my room, the total cost would have been over $2,200. In choosing to DIY the absorbers, traps, and diffusers in my room, the cost came to around $650. That's a savings of nearly $1,550. In full transparency, the cost of DIY always tends to overlook the cost of the tools that are going to be involved or used, and also the skill level of the individual doing the work. So one of the things I think it's best to consider when you're doing a DIY solution is make sure you're able to match up your expectations of quality with your skills and your ability to do that work. So how much absorption is enough? I'll answer a question with a question. What's the challenge that we want to solve? Many calculators are built using assumptions about your room and want to help you without knowing all of the necessary details. So it's always better to start with collecting information and figuring out what you want to achieve given your available resources. Simply, what issues are keeping you from experiencing your ideal room? Most of all, you just need to begin. Choose a room, choose a space. Decide how much you want to spend on that space. Set a budget, set about finding more information, ask questions, look at what other people have done, but you gotta move. Once you have ideas of what might be an issue, you can take the steps to change and test for improvement. Then check and adjust as you see best. It's up to you. The next episode will be the last in the treatment series, and I'll be covering diffusion. I'll show you how I'm building diffusers, and I'll also show you how I'm using them in my room to maintain the liveness that I desire for recording, but also doing any sort of voiceover or video work. So until next time, thanks for watching.